variable number of argument only inside the inside the aggregation functions. Without aggregation function, it will not work. Now, if you have any question, you can put it so that I can hold it. I can give the answers there. You can start doing line number 21, 22, 23, continuing variable number of arguments. So return any value from the function. What input? Okay, to see all formats. Here, see there is inside here it is not possible. What you can do, if you want to read, there's a documentations. There's a open source documentations are provided, python.org. Inside the python.org, if you type on Google, python.org, so there are documentations. So we need to read, suppose I'm doing anything, so I do consider these documentation for any kind of reference. Python.org on Google documentation. So from there I do study a lot and we can use it here. If you want to explore, so you can find it out all these things, but you have to in-depth study for those ones. So documentations are provided in python.org that what are the functions. So general functions are maximum, minimum, and it add this one. Sum is there. Okay. So up to here you are done. Like up to here line number 30, 31, this one. Point. If we see that how actually it is working, each and every bit you can see that, because see here it is working in bits. If I check it out, this one, see this one, because here what is happening, this function is created inside. Or if I check it out, sum function, suppose this is a sum function, this one, and you can say this is a sum function, how it is adding these variable inside, how they are working actually. So for that, let's consider the manual working. So let's consider this line number 1, 2, 3 now. Now let's take these lines now. See each and every bit that how internal working is going on. First of all, you should know that, see student, whenever I'm using this kind of assignment operator, these are a kind of operators. So either I'm writing, here I'm just showing. Okay, let's see here. Suppose here I'm writing. You can take here, see. I'm writing here A is equal to 10. If I want to add one more here, so what I can do, A is equal to A plus 1. Suppose here I'm writing here. So what it will do, it will just take A value 10 plus 1, so it will just make the 11. So A value is, now next time here 11 is the value. The same statement, this is a very simplified way. The same statement, what I can do, I can just write here A plus is equal to 1. This is also similar, just like this one. Same thing as this. So here also what it will do, it will make the similar way addition. So it will take the value of A, 10, okay, 10 plus 1, and automatically it will assign this value to A, so automatically A will be 11. So whenever I'm taking this value, such type of value, or even suppose here this value, these are what? This value. So here you have to consider it as the A is equal to A plus 1. Yeah, or whatever I'm adding, suppose here I'm adding A plus is equal to 10, so it means A is equal to A plus 10. Simplified. Okay, so the same one I'm using it here now. The same one I'm using it here now. Okay. So here you can see this one. I'm just giving the statement one by one. Listen it very carefully that how it is being used. And let's check it out, this statement, s is equal to s plus n. Now I'm explaining each and every bit here so that you can understand how this arguments means internal arguments, variable number of arguments are working internally. Okay, manually it is working inside it. I'm making one function here, some function, where I need to add few data. Okay. Now here, you see here, I had mentioned this and this. Both are same. Okay. Now here, I'm just calling this function. So what are the details inside it? I'm passing any data. Now the first variable I'm taking s is equal to 0 because if I'm making a sum, there should be certain variable which will be holding the data. My addition, my sum it is storing here. And for n is equal to number, it is going to make continuous rotation and return is going to return the final sum here. Let's check it out how it is working now. So same here, I'm writing with def sum function, the same. And then here I'm just calling this variable numbers. S is equal to 0. You can see here the word here I'm writing s is equal to 0. It is a variable which is 0. Now here you can see the next line here, for n in numbers. So it means this for loop will run till the numbers are present there. Now what it is doing, how it is adding the two data, s is equal to s plus n. Okay, I had opened it. See this one, this statement I had opened in this way. This statement I had opened it. Then return is required when the complete data is given. Okay, now let's check it out how these values are running from here. I'm calling it one by one. Now see this line number 2. I'm calling this print sum function, and here 1 and 2 is there, this one. Here see, sum function, so it is going to call the sum function. Here I'm just writing here 1. So what will happen? Inside the number 1 and 2 will go here. So here you will be receiving 1 and 2. After that 1 and 2 is there. So s will be 0. Okay. So in numbers, what is the value? The same value will come here. Which one? 1 and 2. So here you will be receiving the value this one. 1 and 2, the same one. 1 and 2. Okay. Now here I have to make the addition one by one for n in numbers. See students, at a single time try to understand. I'm explaining each and every bit. So in a single run only you have to understand. Try to put your concentration. So here I'm just saying for n in numbers. So what it will do, this n is going to take this first number, this number. 1 is there, inside n 1 is there. So this 1 will come here. This 1, which is this 1, which is this 1 will come here, n, 1. What is this s value? 0. So s value is there, 0 plus 1. Be careful now. 0 plus 1. What is 0 plus 1 is? Always 1. So this s value will be 1. So your sum is 1 here. Okay. Now what we'll do again, it will keep, the loop will keep on rotating till I have numbers. So again this for loop will move to the next index 2. It will call this 2 value here. 2. And this n2 will be coming here, 2. And here, you know, the value has been already changed. So here what it will give you, this value and this value will change. So what it will give you here, s value is 1 now, remember? So here 1, s value is 1 now, so 1 plus 2 is equal to 3. So 3, so s is 3 now. Now it will again check, is there any more numbers? No, there's no more number. Let's end it, finish it. So s is 3. So inside this s, the value is 3. This value will be returned back. and this value will be returned back here. You will be receiving the answer of sum function 1, 2. So internally it is working. Now let's take line number 3. I'm again calling this sum function. So here 1, 2, 3. These 3 values are passing. So 1, 2, 3. The same rotation will be there also here also 3. And here it will, with a 1 you can see how it has worked. With the 2 you can see how it has worked. Now suppose here 3 it came here. So here it will be 3. And here 1 plus 2 is 3 now. 1 by 1 rotation it will be taking. So you can take this data here, this one. You can take this data, this one. I am changing this data now. This one and this one. So what you can do? Already 3 is there now. So 1 plus 2, 3. So inside the S3 is there. And here also n is 3. So this n will come here 3 plus 3. Already S is 3 now. Okay, in next one it will take 1, 2, then 3. So here 6. So what is the S here? S will be 6. So it will return the 6 value. So you will be getting the answer. So internally these are working. And if you are taking this one as a 1, 2, 3, 4, see this one. So you are having this 1, 2, 3, 4. So up to 1, 2, 3, you can see how 6 is coming. And here even 4 is coming here. So 4. So one more rotation it will take with a 4. So here also in n it will work as a 4. 4 plus 6 because S is 6 now. So 4 plus 6. So here it will be 10. And it will return the 10 when it will be stopped. So 10 you will be receiving as the sum. When you will run it here, you will be receiving 10. So each and every bit is working inside it here. And this is working 1 by 1 line. It is working. See the indentation inside the DEF. S is equal to 0 is the part of sum function. And this line, S is equal to S plus N is the part of for loop. And when it is returned, when the work is done. When there is no for loop, data remained, it is going to return it back. Okay, so in this way, internally it is working. Try to do your hands if you want to do. I'm waiting here. Try to do yourself. Above I had written MU. MU means maximum I want to find it out. Function. Certain time we call it a lambda functions also because there is an inbuilt lambda function which will help us to work with anonymous functions here. In anonymous function here, this is a one-line function. Only single line function is there. Okay. So whenever I am having a one-line expression only, one-line expression only. Any mathematical expression I'm having only one line. So there I can use it here. Suppose here I'm just writing very simplified here. I'm taking a into 2. This is a one-line expression. Okay. Suppose here I'm writing x plus y. This is a one-line expression. So these I can use in lambda function and anonymous function. How can I use it here? Whenever I need to work with the anonymous function, so I have to take certain very bits here. I have to use the keyword lambda, number 1, and the variable. Here I have to use the variable. To which variable I'm working. Suppose I want to work with a one variable only, so I'll just write the variable here. And here, wait, just I'm taking question. Wait here. Just a moment. If your answer in if your answer, just a moment, wait. Okay. Wait. I'm taking. For this one, I'm just coming little bit. Wait. I'm taking it. Okay. When you are printing it return, see here, what you have to do, you have to take care for return here. Give your return here. When it will return 1. Actually, if you write your return here, here. If you give your return here, so that becomes the part of for loop. But no, we do not need that. So if you write here return S here from here, double indentation, then you will receive 1 as the answer. But we do not need that. So what it is required, you make only single indentation here for the return. Once you'll return it here, you will be getting the answer 3 because 1 plus 2 is 3. Okay, but if you're again giving the indentation and your return is lying from here, then you will receive 1 as the answer. So here you have to do, just to change it, return and tell me it is working or not. Only single indentation, because otherwise this return will be the part of for loop. From here only it is returning back. Here it will come, only it will not complete its complete part. It will not rotate the entire for loop. No, it will not work there. Okay, we need to rotate the entire for loop. That's why we need to give the return here. So give your return here. 1 indentation only. 1 indentation only, do it and see it here. What you are writing it here. Try yourself and tell me, is it working or not there? Here, acting the mode. Let me read it now. It will take a time. Wait. Taking the corrections. My team will help you. Take it out. Okay. So now let's go ahead with the anonymous functions are also known as the lambda functions. Anonymous functions are returned whenever we have to need to write a one-line expressions only. One-line expressions are just like a multiplied by 2 or x plus y, or I am taking x minus y. Only single line expression it is. How to write it? What is the format and syntax to write it? Lambda keyword I have to write. After that, variable. Those variable which needs to work within the expression. And here, I need to write the expression, one line expression. I can take this one, I can take this one, any of them. Simplified expression here, I'm taking x multiplied by 2. So this is the lambda operation. Now what I'll do here, I'm just saving, I'm just putting this lambda expression into the reference variable, simplified variable. So here I'm just using here LR. Student, this is just the reference variable. It is not fixed that you are going to use the LR only. Okay. Now how to call it? So now I'm making it executed. How? Simply I have to call the reference variable. Inside it, I need to pass the value of x, because one variable value I need to assign it here. So here, suppose here I'm just passing 5. LR5, it will be going to 5 onto the variable and 5 onto the x. So 5 multiplied by 2, everybody is aware with 10. So this will be coming here as the 10. Okay. If I'm taking another one, suppose here I'm taking the another one. I want to add the 2 variables. Okay. So here I want to add the 2 variables. Suppose this one I'm taking. You can take this one. 2 variables, suppose x plus y. How many variables? 2 variables I need to add it, right? Now here what I'll do, I'll simply take this one, 2, see. two variables, so x comma y I need. I have to use the lambda keyword also, lambda x comma y. It means I'm going to take two variables. Now what to do? So here what I'll do, this one, x plus y. So you need to write here expression. Here you need to write the variables and here lambda keyword. So this is overall done. Now I have to store it here. So where to store? You can just write here lx. Suppose any. Now I need to run it. So simply you call lx, the same variable name. And here, this is a reference variable to this lambda function, anonymous function. Here you need to give the data for the x and y. So you can give any two inputs. So suppose here I'm just giving here 10, 20. So it will become as a 10 plus 20 here. So here 10, comma 20. So they will go here 10 and 20. So 10 and 20. So 10 plus 20. So you will be receiving 30. So 30 will be the answer. So in this way, I can write the simplified lambda function here, right? Now suppose here I'm just writing, I want to find out square, okay? A simple things only, square. So what is the square here? I can take here simplified a multiply by 2. So how many variable I will take? Only one variable a. So here I will just write any, suppose here I'll write here lambda x, any variable name, reference variable name here I'm giving. Here I'll just write lambda. How many variables? A. So what I can just write a, then colon, then here I will write the expression. This is the expression, mathematical expression. It is a one-line expression here. So this one is there. How to call it? Just I'll call this one reference variable. Inside it, suppose here I'm passing 3. 3 value here I'm passing. So what will happen? 3 will automatically go where? 3 will go here. 3 into 2. 3 raised to power 2. Okay, so 3 into 3. Right? So you will be receiving 9. So in this way, a simple expression, I can give it here inside the anonymous lambda functions here. So let's go ahead now with these lambda functions now. So see here, lambda functions. Lambda functions, anonymous functions. The lambda function is a small functions containing a single expression. Lambda functions can also act as the anonymous functions where they don't require any name. These are very helpful when we have to perform small tasks with less code. We are going to use the lambda, then bound variable, and then expression. So you can see how easily we had written here. Simply you have to write any reference variable name. You can take it any. Does not matter you are going to take test only. That is up to you. You can take any. The main one is coming here. Lambda keyword, the variable name, and the expression. Lambda x colon x multiplied by 2. So this expression I need to take. This will work and we need to give the value for x. So now here I'm calling it here test 5. So what will happen? This 5 will go to this 5. It will go to x, then 5 multiplied by 2. 5 multiplied by 2. Okay, and it will give you the result here. The similar one, I'm just going here, suppose test 8. So here 8 multiplied by 2. So here you're getting 8. Now suppose here, I am just taking this lambda, x, I want to add the two data. So x and y is there. Two variables I'm taking and I'm adding the two variables. So the value here I'm passing for, this one is the reference variable. You can give any other variable. Test 1 at 3, 4. So here in x3 and 4 will come. 3 plus 4. What is the value of 3 plus 4? It is 7. So 7 will be given here. Here you can see I'm just adding 3. So these 3 value you can just give 1, 2, 3. So 1, 2, 3. So 1 plus 2 plus 3. 1 plus 2 plus 3. So 3 plus 3 is 6. So you will be getting the 6 as an answer. Okay. So now you can proceed 1, 2, 3, 4. Okay. 1, 2, 3, 4 very carefully without making any mistakes in the spellings. It is a lambda LAMBDA. Take care for it and start doing 1, 2, 3, 4 now. Be careful for the syntaxes, please. Expression should be one line only. One line. In this way. And here you can make x plus y, this one, Arjun. So what it will do, it will take this 5 and 10 here. So 5 plus 10. Okay. So because here we do have temperature degree Celsius, I will be passing the degree Celsius temperature and that we are going to convert in Fahrenheit. So for that we need a particular formula. So here I had defined the line number 6 and 7 with a simplified user-defined function. Very simple user-defined function. Whenever I want to convert a one value from another, from degree Celsius to Fahrenheit, so there I need a formula 9 by 5 multiplied by T. So multiply by T means degree Celsius temperature. Whatever temperature I will pass in degrees Celsius, that will be placed here, multiply by 9 by 5 plus 32. So this will become, it will give me the value in degree Fahrenheit. Okay, so this formula we are using. So here what we are passing, I'm asking, okay, Fahrenheit function, if 35 degrees Celsius is there, if here temperature is 35 degrees Celsius, so kindly convey that what could be the equivalent degree Fahrenheit. So what it will take, it will just take 9 by 8. What is the equivalent Celsius? So here it is just giving, okay, 5 by 9 multiplied by here, this is, you are running this. You should know what is this. This is a markdown. This is not the code. You are generating the error. Invalid. Good. This T, this X will go. Degree Celsius will go here. Plus 32. The same thing is there. And then when you're calling it here, suppose you're calling the same reference variable, you are writing at 38.4. If 38.4 degree Celsius is there, it means I want to convert 38.4 degree Celsius to Fahrenheit here. 2 degree Fahrenheit. So the same formula will work and here 38.4 will come automatically and it will give you the response. How much is the data there means. I do line number 31. So here see, I'm just staying here up to here. Wait. So that those who are left out with any